When a Linux machine cannot reach something on the network, the most common beginner mistake is to treat the network as one big black box and start guessing. Someone says the website is down, you try to connect, it fails, and now you are left wondering whether the server is offline, whether your network is broken, or whether your own machine is misconfigured. The reality is that connectivity failures usually land in a small number of categories, and if you can isolate which category you are in quickly, the problem becomes far less stressful. Three of the most important categories are domain name system, DNS, issues, routing issues, and firewall issues, and they can produce symptoms that look similar on the surface. The goal in this episode is to build a fast, calm isolation mindset that lets you decide which category is most likely before you spend time on deep troubleshooting. We will do this without turning the episode into a command tutorial, because the real skill is conceptual, understanding what each layer does and what failure at that layer looks like. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A strong mental model starts with recognizing that reaching a network service usually requires several steps that happen in a consistent order. Your application begins with a destination, often expressed as a name rather than an address, such as a host name. That name must be resolved into an IP address before a connection can even be attempted. Once an address exists, your machine must decide how to reach it, which involves routing decisions about whether the destination is local or remote and which next hop should be used. Then packets travel across networks until they reach the target, and along the way, firewalls and filtering policies may allow or block the traffic. Finally, the target service must accept the connection and respond. If any step fails, you experience a connection failure, but the key is that each step has distinct failure patterns. Beginners often jump to blaming firewalls because firewalls are mysterious, but many failures happen earlier at name resolution or routing. When you learn to walk the chain in order, you stop guessing and start isolating. DNS is the layer that turns a human-friendly name into an IP address, and its role is often misunderstood as something that only matters to web browsing. In reality, many systems rely on names constantly, including servers connecting to databases, package managers reaching repositories, and monitoring agents contacting controllers. A DNS failure is not a slow network. It is a failure to translate names into addresses. When DNS is broken, applications may report that a host cannot be found, that a name cannot be resolved, or they may appear to hang while waiting for resolution timeouts. A beginner might think the server is down, but the client never even learned where the server lives. This is why DNS problems often affect many services at once, because many dependencies begin with name resolution. A key conceptual check in your head is to ask whether the failure occurs only when using names, or whether it also occurs when using known IP addresses, because that distinction points strongly toward DNS or away from it. Routing is the layer that decides how traffic leaves your machine and which path it takes toward the destination. If your machine does not have a correct route to a destination network, it might not know where to send the packet, or it might send it to the wrong place. Routing issues can come from incorrect local configuration, such as missing default gateway information, or from upstream network changes that remove a path. A routing failure often feels like the network is unreachable because traffic cannot even begin its journey correctly. Beginners sometimes confuse routing failures with firewall blocks because both can result in timeouts, but the underlying story is different. In routing failure, the packets cannot find a path, while in firewall failure, a path exists but traffic is being filtered. Conceptually, routing issues often show up as inability to reach anything beyond the local network, while local connectivity may still work. This is why, when isolating quickly, you think about scope. Can you reach local resources? Can you reach your gateway? Can you reach external addresses? The pattern tells you whether your machine knows how to leave its local neighborhood. Firewall issues are about policy, meaning the traffic might be technically possible but is intentionally blocked. Firewalls can exist on your local machine, on the network, on the target machine, or in multiple places at once, and this multiplicity is what makes them feel confusing. The practical concept is that a firewall decision depends on the combination of source, destination, protocol, and port, so you can often reach some services but not others. This is different from DNS failures, which block name resolution broadly, and different from routing failures, which block reaching entire networks. A firewall might allow ICMP traffic but block a specific application port, or it might allow outgoing connections but block incoming connections, leading to asymmetric behavior. Beginners sometimes interpret any timeout as a firewall, but timeouts can happen for many reasons, including routing problems and service-side failure. The firewall clue is usually selectivity. Some protocols or ports work, others do not, even though the destination is reachable in other ways. The best conceptual habit is to treat firewalls as plausible but not default, and to look for evidence of selective filtering rather than assuming it immediately. To isolate quickly, you want to perform a mental sequence that separates name, path, and policy without getting stuck in details. First, you ask whether the problem is name-based, meaning does it fail when using host names but succeed when using IP addresses, or do both fail? If both fail, DNS is less likely to be the primary cause, though DNS could still be part of the story for other destinations. Next, you ask whether the destination address appears reachable at a basic network level, which is a routing question. Routing problems often show up as inability to reach any external network, while DNS problems often show up as inability to resolve names even though external addresses are reachable. Finally, if you can reach the destination network but the specific service connection fails, you suspect filtering, service configuration, or service availability. This chain of thought is powerful because it is ordered, and each step collapses uncertainty. Beginners often do these steps unconsciously, but doing them consciously and in order is what makes isolation fast and repeatable under pressure. Scope-based reasoning is one of your strongest tools in this topic because it prevents you from overfitting to one symptom. If only one website fails but others work, that suggests the problem might be on the remote side, or it might be name resolution specific to that name, rather than a general routing failure. If all external names fail but direct IP addresses work, that suggests DNS. If nothing external works, including known IP addresses, that suggests routing or a broader network outage. If one protocol works, but another fails, that suggests firewall or service level issues. The important idea is that you do not need a long list of tests. You need a few well-chosen comparisons that reveal whether the failure is broad or selective. Broad failures point to early layers. Selective failures point to later layers. This is the same reasoning pattern you have used in other troubleshooting topics. Broad symptoms often indicate a shared dependency failure, while narrow symptoms often indicate a localized cause. Another beginner misunderstanding is assuming that DNS, routing, and firewall are independent and cannot interact. In reality, one layer failing can create misleading signals that appear like another. For example, if DNS points to the wrong IP address due to stale data, your routing might be fine, but you will be trying to reach the wrong destination and seeing failures that feel like service issues. If routing is misdirected, you might send traffic to a network that drops it, which can look like firewall filtering. If a firewall blocks DNS queries specifically, name resolution fails, and it may look like DNS server failure even though the servers are reachable. This is why the chain approach matters. You isolate by testing assumptions, not by trusting labels. Each layer has a role, and by confirming whether that role is being fulfilled, you narrow the root cause even when layers interact. The mature mindset is to treat the network as a stack of contracts, and to test whether each contract is holding. It is also important to remember that local machine configuration can be the root cause even when the rest of the network is healthy. Local DNS settings might point to unreachable resolvers. Local routing tables might be missing a default route, or local firewall rules might block outbound traffic. Beginners sometimes assume the network team broke something, but local misconfiguration is common, especially after system changes, virtual machine migrations, or network profile switches. The first response habit is to avoid blaming any external party until you confirm whether the failure is local or shared by multiple hosts. If multiple machines in the same environment fail in the same way, that suggests an upstream issue. If one machine fails while others succeed, that suggests local configuration. This again is scope reasoning, but applied socially and operationally. You compare behavior across systems to locate the failure domain. That comparison often saves hours of confusion because it tells you where to focus investigation and who needs to be involved. Another important concept is asymmetry, because firewalls and routing policies can behave differently in each direction. A connection attempt might leave your machine successfully, but the return traffic might be blocked, misrouted, or filtered. To a beginner, this looks like a timeout, which feels like the destination is down, but in reality the destination might respond, and the response never reaches you. Asymmetry can come from stateful firewalls that track connections, from routing that differs inbound and outbound, or from security policies that allow one side, but not the other. You do not need to diagnose asymmetry in detail to isolate quickly, but you should know it exists because it explains why some failures feel inconsistent. It also reinforces why DNS is often easier to isolate first. Name resolution is a clear request and response behavior, and if it fails consistently while other address-based communication succeeds, that points to a specific layer. When address-based traffic fails in a way that looks like timeouts, you keep asymmetry in mind as a reason that routing and firewall must be evaluated carefully rather than assumed. The phrase minimal commands in the title is really about minimalism in thinking, not about refusing to look at evidence. The best troubleshooters do not run dozens of tests. They run a few tests that are chosen to distinguish categories. In your mental toolkit, you want comparisons that separate name from address, local from external, and protocol from protocol. Each comparison is like a fork in a decision path that eliminates many possibilities. If name fails but address succeeds, you go toward DNS. If both fail broadly, you go toward routing or broad filtering. If basic reachability is fine but a specific service fails, you go toward firewall policy or service availability. The point is to use evidence to choose a branch, not to keep testing randomly until something changes. This is a reliability skill because it reduces time to isolation and prevents you from making changes that hide the root cause. In real operations, being able to say it is DNS, it is routing, or it is filtering is often enough to route the issue to the right team and to protect your system while the fix is made. As we conclude, the most important result of this episode is that you can mentally classify network failures without needing to be an expert in every protocol. DNS failures stop the process before it begins by preventing names from becoming addresses, and they often show up as host not found behavior or widespread name resolution issues across many services. Routing failures prevent packets from finding a viable path, and they often show up as inability to reach external networks even when local connectivity is present. Firewall failures are policy-driven and often selective, allowing some traffic while blocking other traffic based on protocol and port, and they frequently show up as service-specific timeouts or connection refusals when the destination is otherwise reachable. Fast isolation comes from walking the chain in order, using scope and selectivity as clues, and avoiding the beginner habit of assuming firewalls by default. When you can do that, you turn a vague complaint of cannot connect into a precise statement about which layer is failing, and that precision is what makes troubleshooting efficient and professional.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.